Okay, everybody, good morning. Today is day 3 of our series in sequences unit, and quite frankly, it's our last day. So there's just 3 quick days. We had arithmetic, we had geometric, and now today, the last day, we have a recursive sequence or recursion. And a recursive sequence is a sequence that follows a pattern, but the pattern is based on the previous term that you had instead of based on adding or multiplying every time. So the idea of recursion or recursive again is that you need to know the first term in the sequence and you need to know the rule. And then you apply the rule to each successive term. To each term. I don't know if that totally makes sense, but we might say the first term is 5. And the rule is multiply whatever that term was by 2. Let's actually write this out, but you don't have to write this if you don't. If the first one was 5, and the rule is 2 times whatever the first one is, it would be 2 times 5, which would make 10. And then I'd do 2 times 10, which would make 20, and then I'd make 2 times 20, which makes 40. But suppose the first number's 3, then it would be 2 times 3, which is 6. Then I would do 2 times 6, which would be 12. I do 2 times 12, which is 24. So the rule is going to apply to whatever the last term was. And by knowing the first term, you just have to plug it in and then apply the rule to that answer every time. So if you need the 5th term, there's no way to just find the 5th without finding the 4th, and you can't find the 4th unless you find the 3rd, which find the 2nd, find the 1st. So the idea is you take the term that they give you to start it off, apply the rule, and then take that answer and apply the rule to the answer. Find the answer again, apply it again, apply it again. So it looks confusing, and it sometimes is something that students struggle with. It's not difficult, it just looks tricky when you see it. So here's our first example. Find the first 4 terms of the sequence defined by a sub 1 is negative 4, and an equals an minus 1 plus 5. I'm going to wait 1 minute so you can write that down. The part that's confusing is this. This is like, what is this an minus 1? So all that means is my first term is negative 4. But when I go to find my second term, it's going to look like this. That's what that's saying. That whatever this number is, suppose it's a 2, that's 2 minus 1, which is 1. And what is a sub 1? A sub 1 is negative 4. So I'm going to put negative 4 in where a 1 was, and my answer here is 1. When I go to find the third term, the rule says take the second term and add 5 to it. So the second term that we just found was 1. It's going to be 1 plus 5. My answer here is 6. And then when I find a sub 4, that is the same as a sub 3 plus 5. And a sub 3 we just found was 6. 6 plus 5. My answer here is 11. So the first 4 terms would be negative 4, 1, 6, 11. So what that n minus 1, we're not really subtracting 1 from anything. All that means is you take this number and you substitute it in right there. And then you take this number and you substitute it in right there. And you take this number and you substitute it in right there. So if we had needed the next term, the 5th one, it would have been 11 plus 5, or 16. And the next one after that would have been 16 plus 5. It's just, this n minus 1 just means use the term that was right previous to it in this spot. Okay, let's do one more. Example 2, it's find the first 4 terms again. They can ask for 4, 3, 5, but they usually don't ask for like 10 or something because that would be a lot of work. It's usually just the first 5, something like that. Find the first 4 terms of the sequence defined by a sub 1 equals negative 3, and an equals an minus 1 minus n. So instead of adding 5 as the rule this time is going to be subtract n, whatever n is. Now I can write it out like I did last time. But when you have a recursive sequence, number one, it might say recursive or recursion up in the question, but you'll also notice that you get a rule and you get a first term. And wherever you see the n minus 1, this a n minus 1, what's going to go into that spot? This negative 3. So to start it off, to find the second term, it's just going to be negative 3 minus 2, because 2 is the n, which is negative 5. Oops, oh shoot, sorry about that. And then to find the third term, we're going to do negative 5 minus 3. To find the fourth term, we're going to do negative 8 minus 4. If they needed the fifth term, which they didn't ask for, but if they did, do you know what it would be? Just negative 12 minus what number this time? 5. So again, the idea is that you don't really subtract 1 off of anything. You just take the answer that you just had. The first answer plugs into the second one there. The second one plugs in there. Then this one plugs in there. And this one plugs in there. And this time, instead of adding 5 as my rule was minus n, so I had to subtract whatever this little number was. All right, so that was one kind of idea today. Recursion or a recursive sequence is the kind that seems to be most frequently given on the Regents. And then there were 2 other things that I just wanted to talk about. I wanted to just show you, if you have a sequence like 2, 4, 6, 8, 10, something like we did on the first day, this is arithmetic, right, because I'm adding 2 every day, that you actually now could write this in 2 different ways. If they asked you to come up with the formula or the rule or a sub n, we had this rule. Hopefully you're getting good with this memorized. I don't know if you have it memorized yet. Where an will equal 2 plus n minus 1 times 2. So this is the first term. This is the common difference. We did this weird kind of distribute from the back, right? So we end up with an equals 2 plus 2n minus 2. And that 2 and negative 2 drop out. So an equals 2n. That is called the explicit formula that would yield this. So if I need a sub 5, I can just do 2 times 5 and get 10. The fifth term is 10 right away, quick. But you really could write it as a recursive sequence as well. And if you wanted to write it as a recursive sequence, you would say a sub 1 is 2. And the rule is take the term that you just had and do what with it? Add 2 to it. So that would also be an acceptable answer for writing the formula. So if I do 2 plus 2, I get 4. If I do 4 plus 2, I'd get 6. 6 plus 2, I'd get 8. So this is just a different way to write that same sequence of numbers. The reason I'm not real fond of the recursion is if I need the fifth term, I can't just plug in a 5. I have to find the first one, plug it in to find the second, to find the third, to find the fourth. But this rule will just let me jump right to the fifth term automatically without finding all of the ones in between. We can do the same thing with the geometric sequence, so I'll just show you that. Explicit, remember, means using the formula that we used on the first day, something like that. So in this example, it would be 3 times 3 to the n minus 1. And then the recursive sequence, I would say a1 is 3, and the rule is 3 times a n minus 1. So the rule is, this is the first term, and just multiply 3 times the first term, I'd get 9. 3 times 9, I'd get 27. 3 times 27, I'd get 81. So this maybe is a kind of a draw for me. They both seem equally. But again, if you need the fifth or seventh term, here you could just plug in a 7 right away and get the answer quick. Here you would have to go through the process of finding the second, third, fourth, fifth, sixth. All right, so that was one other quick just kind of disclaimer. And then the last thing I wanted to show you today, and this will kind of finish up our series in sequences, is that working backwards and writing things in sigma notation. Summation notation or sigma notation was that big capital E that you learned in the last unit, and we went forward last time. I just gave you this and you had to evaluate. Now I want you to be comfortable working backwards. So if you have a series of numbers like this, 15 plus 18 plus 21, and you need to write it in sigma notation, the first thing you need to do is understand the rule, figure out what's going on. So to find the rule, I would use the formula that we always start with, almost always, when we're looking for the rule, which is this. So it's going to be a sub n equals 15 plus n minus 1 times 3. Distribute from the back like we do. So I got an equals 15 plus 3n minus 3. My final answer here will be an equals 3n plus 12. That rule tells you what's going to be right in the front part of the sigma. That is the rule. And then you just have to figure out how you want to start and what you want to end at. I want to start always at 1 if I've done this official rule thing. So 3 times 1 plus 12 would give me 15. 3 times 2 plus 12 would give me 18, etc., etc. But now be careful at this point that you don't put a 42 up here, right? I want 3 times something plus 12 to equal 42. So you could do some guess and check, or the official way to do it would be to write 3n plus 12 equals 42, and then just back this up and figure out what n is. So we'd subtract 12, 3n equals 30. My answer here, n equals 10. There are 10 terms total here, so that top number is a 10. And this would be our answer. So the a sub n business gives you the rule that's going to go out in the front, and then you just have to figure out the top and the bottom numbers that would lead to this. All right, one more example with that same idea, and we're finished for today. I've got 7, 11, 15, 19, etc. They want sigma notation, so I would start with the an formula. Oh, by the way, also, if you want to try this on your own, you could pause right now and see if you can work it out, and then check in a minute if you want. I don't know if that's too quick or that's okay. I did that distribute and I combined all in one. So there's my rule. That means 4n plus 3 is going here. N starts at 1 because 4 times 1 plus 3 would make 7. Now we can do what we did up here. I can set this expression equal to 35 and solve it. Or because they've listed them all, I can just count 1, 2, 3, 4, 5, 6, 7, 8. There's going to be 8 terms, so this top number's an 8, and I'm done. If not, if you just want to double check, you might do 4 times 8 plus 3, and just make sure, oh yeah, that does give me 35, the top number. When it subs into here would give me that. And that's my answer there. All right, so that's it. You've got arithmetic, geometric, and now recursive. We've got one nice day of review and practice with the recursion today, and then probably just a quiz on this. You won't have a test because it's a short unit. So thanks, have a great night, and I'll see you tomorrow.